Good morning all. Today we talk about, means earlier session we talk about the threads, thread memory allocations and all the basic stuffs. In the today's session we talk about what is mean by thread. Just to recap on from the first session, life cycle of a thread and how to create the threads. Okay, so thread we know that each process, like a process, is divided by multiple part of a threads to work faster or simultaneously complete this work of this process, and all are the lightweight sub processes. Okay, that's the definition, by the definition of the thread. For example, in the last session we talk about the word application. This is a word application. Okay, this is a word application, and word application we are importing one image which is size is a 10 MB. So this process took a lot of time. Okay, apart from that we are writing something in this word document, writing something. Okay, and we are copying some data or we are pasting some text from out of application. Okay, these are the three things we are doing. So this process is a word process. Okay, this is a process, but there are three subtasks. One is a image sourcing, another one is a writing, which we are writing into application, and third thing we are copying something or we are exporting as a PDF. So this is the T3. So combining our T1, T2, T3 word process came into picture, but each one have a different task, and the word process divided the task at a third level. Okay, that's the basic definition of a threading. With the example, we'll move ahead with the definition or a life cycle of thread. Okay, so whenever thread is getting created, okay, one process at least have one thread. Okay, that's why we are saying always process have at least one thread. Okay, so whenever thread created, the new state came into new state, which is by t1.start. Whenever we are calling start method, that time that thread came from new to ready to run state. Means whenever we say start, that means it is eligible or it's ready to run state. Okay, after that the R we already discussed about in the last session, where thread scheduler are there into CPU or OS, sorry, in OS. So what thread scheduler will do, he have lot of processes and threads. Okay, combination of processes and threads. So he generally assign the CPU based upon the priority. Okay, so based upon the process priority that are assigned the CPU, because all are ready to run state. So whenever CPU gets assigned to that particular thread, then that thread get executed. That's why we are saying if thread scheduler allocated the CPU, the task came from ready to run and it's a part of a running. Okay, so after the running there are multiple states. Suppose you are doing something work and you need to wait for other thread came in at that point. So that time we are saying that t2.join means we are waiting for other threads. In that thread what happened, waiting state for job completion, and again that thread move into ready to run status, because this is waiting for other processes. Apart from that, there are multiple cases where we are moving from running to other state. One is we are waiting for other completion. Apart from that, okay, CPU is assigned, my work is completed, so I can go and complete my process or complete the thread. So that become a dead, like t1.stop or complete. Whenever that method get called, that means my work is completed, so there is a no use to keep me alive. So that thread go into dead state. Okay, after that, suppose the thread is required some resources, or by forcefully that we are pushing that thread into sleep. In that case, like thread.sleep method push that thread into sleeping state. Okay, from a sleeping we are passing some milliseconds or a microsecond time. So after that time, that method push to the ready to run, and then same again ready to if CPU allocate CPU, then it move into running state. Apart from that running, if you are saying wait, we want some IO resources or any resources and we are waiting on that object or a resources, that time object.wait, we are saying you means this thread is waiting on a particular object. In such cases that thread move into wait state, and after this lock or after this some resources or that object lock get unlocked, then the notify to this object, and this object again go into ready to run state. Okay, there are fourth case where we are suspending that thread. Means in a running this stage is the running, but due to some exception or any unprecedented situation, that thread suspended, and that thread again move into ready to run state by calling resume method. Okay, these are the four steps from where the thread from running to move into different step. First is the join method. After calling join, that is waiting for completion. After the sleep, means for a particular time thread move into sleep. After that waiting state, object.wait, if you call that, also the object get into next state, and the suspend mode. Okay, by these four method calling, our thread move into ready to run, and after next few cycles, whenever task thread scheduler assigns CPU for this, then the thread again came into running mode. Okay, there is only case where after the completion of the thread or the by forcefully stopping that thread, then only that thread move into dead state. Okay, yeah, this is the thread life cycle. If you have any questions around that, let me know. We can discuss in a more details in a next upcoming session. Okay, next point is the how to create a thread. First is by extending a thread class, and next way is the by implementing a interface, runnable interface. Okay, thread class and the runnable interface. Okay, one is the way by implementing by extending a thread, and another is implementing by interface. Okay, we'll check about the first how to create. Okay, so first you need to, in object oriented program, first you need to create a class. Okay, so here I mentioned a class where multi and extending a thread class. Okay, this thread is a class. You can just open that source code R. So in a thread class you will get multiple methods and you can implement that method. So this is a thread class. So here we are writing a run method, overriding a run method, and inside that we are saying that system.out.println new thread is a running. Okay, this is the run method which is overriding from that thread class. Thread class also have the run method, but still we are overriding into R class. Apart from that, this is the entry point of R application. Okay, because we are mentioning public static void main and multi one, T1 is a multi. So T1 is an object created and we are saying T1 dot start. Okay, so if you are a new, you will get that first question that T1 is this class and we haven't start method. So how can it directly call that a start method, because we are not defining any start method. Okay, so T1 dot start means that if you just came here, if you see here, like after the T1 start new thread came into ready to run state. Okay, so whenever T1 dot start happen, that this is your current thread. Okay, from CMD you hit the enter, the thread start running from here, the object creation happen, T1 dot start happen. From this line T1 dot start, two thread is created. There is one existing legacy thread which is executing and print the old thread is running, and from this line that run method is getting called, and that is a different thread. Okay, so after in a run method the next code execution happen where the print like a new thread is running. So at this line you will see that old thread is running, and at this line new thread is happening, but our CMD output is the only single window, so we will get all the output in a same window. But if you assign some name to the thread, then you will get to know in a detailed way that two thread are created and two thread are printing some extra steps. Okay, so first if there is any doubt on the first way, let us know. We'll cover in a deep details in a second. So this is the second type to create a thread. Okay, so by implementing a runnable. Okay, so runnable is an interface, and here run is the method which need to be defined. Okay, because interface have some methods we need to write code for that. So public void run, we are doing the same thing, and this is the entry point like earlier also. This is the start point for our application. Here we need to create a thread object because we cannot create the object of an interface. So this is a multi3, this is our class name. We are creating object of this and passing that object into thread, like this is an object, and we are calling T1 dot start. So whenever you want to create a thread, that time every time you need to create a T1 dot start. Okay, so earlier also same way exception, when we say CMD, from CMD we are hitting enter for execution of this main class. Till that only one thread is there because we created object, here created an object, after thread object also created, that time also one thread is there into our system. But then T1 start is happening. Okay, when we hit the T1 start, that time this run method is for different threads are executing this run method, and this line of code is our legacy thread who created that multi object and thread object, this thread executing this code one. Okay, so earlier thread executing the same way, but from T1 dot start new thread is coming and he will execute the run method. Okay, and this is a legacy thread, means the existing execution happen. So this is the way that thread get created and executed the function. Okay, yeah, that's it for today's session. Let me know if you have any doubts and upcoming sessions about, if you want upcoming session information. Yeah, bye.